In part 1 of lecture 5, we will answer the question, how do flip-flops work? This is a basic RS flip-flop implemented using NOR gates. R stands for reset, clearing the flip-flop to 0. S stands for set, setting the flip-flop to 1. If both S and R are cleared to 0, there is no change. If Q was 0, it remains 0. If Q was 1, it remains 1. If S is 1 and R is 0, the flip-flop will be set to 1. If R is 1 and S is 0, the flip-flop will be cleared to 0. But R and S cannot both be 1. This will lead to an indeterminate state where both Q and Q prime is 0. This is the basic flip-flop implemented with NAND gates. Here we use 1 as a baseline for S and R, with the flip-flop using 0 for action by its inputs. If both S and R are set to 1, there is no change. If Q was 0, it remains 0. If Q was 1, it remains 1. If S is 1 and R is 0, the flip-flop will be cleared to 0. If R is 1 and S is 0, the flip-flop will be set to 1. But here, R and S cannot both be 0. This will lead to an indeterminate state where both Q and Q prime is 0. Let's start with a basic scenario. The flip-flop holds 1, and both R and S are 0. We will start at the 0 value for R and the 0 value for Q prime. Q prime's value being transmitted to the same NOR gate to which R is transmitted. The NOR gate has two zeros. 0 or 0 is 0. Not 0 is 1. And Q's value remains the same. The 1 from Q goes down to the NOR gate that receives S's value of 0. The 1 from Q and the S input of 0 go into the NOR gate. 1 or 0 is 1. Not 1 is 0. Q prime remains 0. Now, let's try clearing the flip-flop by setting R to 1. The NOR gate on top receives R as 1 and Q prime's value of 0. 1 or 0 is 1. Not 1 is 0. This is Q's new value, 0. Q's new value of 0 goes into the NOR gate at the bottom. S's value of 0 also goes into the NOR gate. Q's new value of 0 and S's value of 0 both go into the NOR gate at the bottom. 0 or 0 is 0. Not 0 is 1. Now, let's look at the case where S is set to 1. We will start at the lower NOR gate. It receives Q's value of 1 and S's value of 1. 1 or 1 is 1. Not 1 is 0. Q prime's value of 0 goes to the upper NOR gate. And at that NOR gate, it is combined with the 0 of R. The 0 from Q prime is ORed with the 0 from R. 0 or 0 is 0, not 0 is 1. And in this case, it sets Q again to the value of 1. Let's look at one last example with the RS flip-flop. This time the flip-flop is cleared to 0, and R and S will both remain as 0. We'll start with the upper NOR gate. The upper NOR gate gets from Q prime the value of 1, and from R the value of 0. Let's start at the upper NOR gate, which gets the 1 from Q prime and 0 from R. 1 or 0 is 1. Not 1 is 0. This clears Q's value to 0, which is the value it already held. In this slide, we AND both R and S with a clock pulse. Since R and S can only transmit a 1 to the flip-flop when the clock pulse is 1, it will synchronize the flip-flop.